Hello, Professor. I'm interested in joining one of the theory groups. Can you tell me about your current research interests?
So we have this new project, and it's based on a few observations. First is that flies that fly around, they're very small. Very small, they move very fast, right? And you know other things that move, they're small and they move very fast, don't you? Like electrons. Electrons are small, they move very fast. So I'm proposing that flies are actually oversized electrons. And we can use that. We can use that to actually understand flies better because we already understand electrons.
So for ages we've asked the question, where do babies come from? Well, now we have the answer, nanokids.
Having already had a great deal of success with the folding process, we're now interested in moving on to other stages of the laundry system.
For example, the uncertainty principle. You remember that, right? Heisenberg's uncertainty principle, delta x delta p greater than or equal to h bar over 2. Flies, just like electrons, are uncertain. So if we try to actually swat a fly, then we can predict its position, but then we can't predict its momentum because it's moving very fast. So just like electrons, flies have an uncertainty principle, and we can use that. We can use that to understand better how to manipulate flies.
Nanokids are the excellent example of the structure-function relationship. For example, the round-headed part, seen here, becomes the head of the baby during gestation.
We believe that the best direction to go is initially to model what happens to laundry inside the drying machine, which will enable us to determine what happens to all the socks that seemingly disappear when you do your laundry.
And this also explains why electric fly swatters are so great. I bet you've always wondered about that.
Therefore, we're proposing a new synthetic target of a baby.
This is going to be an amazing advance. This will save the American consumer, on average of tens of dollars a year in sock purchases.
Based on this hypothesis, I predict that rotting food could be a great energy source.
Our current models suggest the formation of both baby and baby derivatives. Of course, we currently have no practical knowledge of how to synthesize these compounds, such as this one. However, I'm sure our synthetic colleagues are up to the challenge.
So the plan is to extend folding at home to include drying at home. And over the next decade, we plan to expand into many other areas, including washing at home, ironing at home, to complete a whole computationally laundry suite.
We're also going to apply this model to create a fly-based solar cell, which will solve all of the energy problems of the world. Don't you want to be involved with that?
This could potentially revolutionize the fields of embryology and chemistry, and with this innovation, a new niche market has opened itself: nanotoys.
This sounds hard, but it's actually not that hard. This will be accomplished by connecting, just all the washers and dryers in the cloud. We expect this will give us, roughly over 1 exaflop of computing power.
Do you know that the word solar is derived from the Latin word sol, which means sun?
Our cutting-edge spring modeling techniques for allowing us to do a wide variety of new products, including ring polymers, slinkies, and nano pogo sticks.
In addition, we plan to launch something really, really cool. We plan to launch Dry It, an online puzzle game that allows lay people to help us locate our missing socks.
Plants are very good at absorbing sunlight. And from what I've told you, it should be clear by now. It's probably clear to you already. We can use flies to extract sunlight from plants and then make progress in solving the energy crisis.
Currently, we're crunching the numbers on our nano jack-in-the-box, and we're really excited about the preliminary results.
So that would be your research project for the next 5 years.
If you could just sign here, please.
Sure.
Thank you.